Hi everyone, my name is Xiaomeng Yi. I'm a senior researcher in Zelis. The paper that I will present is titled Milvus, a purpose-built vector management system. Milvus is an open-sourced project. This paper is a joint work of some major contributors of Milvus. Dr. Jianguo Wang is currently an assistant professor in Purdue University. The major part of this work is done when he's at Zelis. When talking about big data, the first thing that comes to our mind is usually about data volume. But there's another trend. Data are becoming unstructured. We are seeing more and more unstructured data like images, videos, social networks, and geospatial data. It is predicted by IDC that by 2025, that 80% of global data will be unstructured. An essential approach to analyzing unstructured data is based on vectors. Typically, it's a two-step procedure. It first transforms data to vectors and then performs an analysis in the vector space. Take image search, for example. A common practice is to transform all the images to vectors. The method is designed so that vectors of similar images are close in the vector space. When a query comes, we also transform the query image to vector and perform vector similarity search, or what we call nearest neighbor search in the vector space. After getting the result vectors, we return their corresponding images to users. The first step that transforms data into vectors is usually done by machine learning models. In Milvus, we focus on the second step. We began to develop Milvus in October 2018. After 1 year, we open sourced it. Last year, it was adopted by LFAI Foundation as the incubation stage project. And we have just released its 1.0 version at the end of this March. Now we have 139 contributors and around 6,200 stars in GitHub. There are more than 1,000 companies and organizations that are using Milvus. We have made around 3,000 of communications with our users. Through these communications, we summarize several common requirements. Some of the requirements are about efficiency. We need to be able to handle billion-scale vectors with frequent insert operations. In the meanwhile, ensuring efficiency of query processing. We are also required to support advanced query semantics. In addition to vector similarity search queries, our users also demand for more complex search logics, such as vector searches with filter conditions on attributes and a combined search on multiple vector fields. To satisfy the requirements, we made a series of efforts in the design and implementation of Milvus. We will introduce this in the next. First of all, we will take an overview of system design. In Milvus, we have a component called request handler to receive and respond all requests from user applications. For data insert requests, inserted data are first stored in memory as memory asynchronous processing to reduce the response latency of data write requests. We use the LSM structure and the snapshot isolation to address read-write consistency problems. We also support distributed processing with compute storage separation and stateless computing instances. Next, we introduce some example applications that use Milvus to manage vector data. The upper two applications are based on image search. In these applications, images are transformed to vectors, which are stored and searched in Milvus. In Qichacha, a leading Chinese application for searching business information, Milvus is used to find similar trademarks for its customers. 贝壳找房 is one of the biggest real estate trading platforms in China. They use Milvus to search for houses and apartments with similar floor plans. The third application is about chemical structure search in Wuxi AppTech. It is a major company that develops new medicines and medical devices in China. In their application, chemical structures are encoded as high-dimensional vectors so that similar structures will have similar embedding vectors. By using Milvus, they reduce the time of similar structure search from half an hour to just a few seconds. Milvus are also used in other applications like video search, chatbots, recommendation engines, and so on forth. You can check our homepage for more details. We conduct performance evaluation on Alibaba Cloud with 2 billion scale datasets. We compared Milvus with 2 open source systems and 3 commercial systems. In previous slides, we already presented evaluation results on optimizations and advanced queries. Here we show the comparison of vector search performance using 2 major index types. We can observe that Milvus outperforms its competitors in almost all cases. To conclude our work, when developing Milvus, we met requirements on vector data management from versatile applications. To satisfy their requirements, we designed and implemented Milvus with both systematic and algorithmic considerations. In the future, we will try to adopt a cloud-native architecture in Milvus. And we are also considering using FPGAs to accelerate Milvus. Okay, that's all my presentation. Thank you for watching this video.